So good afternoon to one and all present here, and today we're going to cover QT-03 basics quantum programming. So our topic is object-oriented programming, data storage, and memory allocation. So if you are looking at the subject, each and every topic itself a separate course. Okay, data structure separate course, object-oriented programming separate course. So in this lecture, we able to give a brief outline about all those concepts. Okay, not each and every topic is able to cover under this wider topic. At least we try to give a glance about it. Okay, that is what the intention. Is my slide changing, sir? Object-oriented programming first slide.
Yes, sir. Yes, sir.
Okay, thank you, thank you. If you are looking at uh, the formal definition of object-oriented programming, is a programming paradigm that organizes software design around objects rather than functions and logic. So if you are looking at the alternative form of object-oriented programming, which is hierarchy-based. Hierarchy-based or a flattened programming concept. Example C. Okay. So whatever the language offers, you need to use. You need to use according to their syntax or commands. So this is about the hierarchical based language or flattened straightforward language. Okay? If you know that language, you can easily build the solution, right? But why we are writing the program? Because of real world object entities. So objects are real world entities. Objects are real world physical entities. You can say physical entities. So we are writing program for this real world object. So if you are writing a program object oriented perspective, we are writing program for interaction between all these objects. So this is fundamentally based upon how the object interacts, okay, interacts in their environment, right, rather than functions and logic. So everything you're looking at as an object. So that is the fundamental difference between C and structured language, okay, between object and theory. So here object is centric. So object is centric of your programming paradigm. Okay. So the object could be anything. So each and every object contains so many attributes, so many properties, values. Okay. So we are able to control these attributes and values, okay, with the help of all these concepts. Okay. So we'll cover what are the basic concept covered in object-oriented programming. If you're doing programming using object-oriented, what is the advantage we're going to get? Modularity. So modularity in the sense you are able to divide your concepts. You are able to divide your problems. Okay. You are able to solve part by part. So this is the advantage of modularity. Okay. You're able to subdivide your problem. You're able to build solution part by part. So most of the real world solutions are so big. In first hand, we cannot solve in a single stitch. Right. The second advantage is maintainability. If you're able to do modularization, if you're able to divide your problem into smaller chunks, then it is easily able to maintainable. So everything have a interrelation, okay, in object oriented, and every interrelation have some access and restriction. And usability. If you created some solution, some coding, you can use it again and again. So if you are using all this stuff in C, the program is different. The idea is different. Whatever you're able to create in C, okay, you're able to do in C++, Java, and Python. So here I want to mention the language difference. So C is structured language. structured language, C++, Java, Python belongs to object oriented. So in short form, we'll call OOPS, object oriented programming. So whatever you're able to do in C, you're able to do in C++, you're able to do in Java, you're able to do in Python. Okay. Whatever you're able to do with these three languages, you're able to do in C. Some restrictions are there, but most of the time, whatever you do in one language, you're able to do in other language in different forms. In different forms. Okay. So the key principles of object-oriented lies in encapsulation, okay, inheritance, and polymorphism and abstraction. So these are four key principles we identify. If you want to learn object-oriented in a structured way, these four will help you. Right? So we'll discuss one by one, if it is possible with the a program also. So the first concept is encapsulation. It is about bundling data and methods that operate on the data into a single unit while restricting direct access to internal details. So take an object, take some real world object, uh, take an example of a car. Okay, this is an object. This object contains so many facts. Okay, length of the car, or price of the car, or color of the car. Okay, so this is data, right? So what you can do, uh, you can recolor car, or repaint, or you can polish. So all these things will come under function. So in Python and C++ and Java, you may call it as method. So we have a clear-cut difference between your data and function or method. Okay, what we are doing, we're going to bundle this data and function together, and this process is called encapsulation. So in object-oriented programming, everything we are looking like an object. Okay, individual object. Those object will interact with the environment, with the other object also. So each object contains some data, and each object could have some functionality also. So it is combination of both. Okay, if you are adding this data and function together, that process is called encapsulation. So we can look at like this. So all your data you able to store under variable. So all your data will be stored in the form of variables. Okay, what are the functions? What are the functions you're going to perform over your data? Over your data. Okay, it is said to be methods. So if you're combining data plus methods, okay, in a single form, that is called class. That is called class. Okay, so class will give idea about an object. So class will give idea about an object, or it is a abstract quantity, So imagine like this. So if you are new to computer science, if you are new to object oriented programming, right, you can consider in this way. If voice is not there, please rejoin, try to rejoin. Okay, the second concept is inheritance. Okay, so inheritance is a mechanism where one class derives properties and behavior from another class, promoting code reuse and hierarchical organization. So it is like inheritance between each and every object. It is like a family hierarchy. Okay, so what are the methods, what are the properties, qualities from your father you are able to inherit from him. Okay, so whatever the DNA characteristics, all these physical traits, whatever you are carrying, your child will also carry, right? So if you have a class, that class could be called as base class. Take an example of father. Okay, whatever the characteristics father holds, DNA holds, okay, all those information are derived to children, so this is how real world object interacts, right? Okay, so we have father, we have mother. From father and mother we are getting all our DNA combination, right? So it is like derivation, inheritance. Okay, so imagine a little complicated stuff. So here class is a vehicle. Okay, so vehicle has some property, vehicle has some reference. Okay, vehicle used for transportation. So we are using vehicle for transportation purpose. Okay, so what are the properties vehicle could have? Okay, so vehicle could have the fuel, right, the capacity, and applying brakes. So all these are functions. So class contains some data. Class contains some data along with functions or methods. Okay, so if you have generic idea, so class is like generic idea. Generic idea. From generic idea, you're able to derive a different types of vehicles. So take an example of bus. Okay, so bus is somewhat bigger. Bus will carry passengers. Okay, so according to the purpose, okay, the whole attributes of this class about to vary. Okay, so if you take example of car, so car is somewhat smaller. Okay, so car is somewhat smaller. So whatever the bus have property, definitely it will be able to vary. So here the variation will come, but above this, it is general. It is general, or you can say common. You can say common characteristics. So here you can have variation. So this is idea about class and object, right? So next, if you're looking at yeah, day-to-day life classification, biological classification, so animal have the uh, uh, animal is a larger kingdom. Okay, larger category of kingdom, animal kingdom. From animal kingdom, they able to inherit some properties. So according to the classification, it could be dog, it could be cat. But both of these animal carry carry commonality between them. Commonality between them. So this property is called inheritance. So deriving from a base class to uh, subclass. Okay. So otherwise you can say it is a parent class. It is a parent class. It is a child class. So multiple alternative terms are there. Synonyms are there. Right. Base class, derived class, or base class, subclass. You can say in any number of terminology, but idea remains same. So next, polymorphism. So polymorphism is somewhat interesting factor. The ability to use the same method for different implementations, allowing flexible and scalable code. Suppose I will go with an example. If there is a man can be a casual outfitter. Okay, he can go to office. Okay, yeah, he can go to sales for sometimes, right? He can do meetings with client, and he can go for shopping. Okay, and he can be a complete family man. Okay, the object is same, the person is same, but depends upon the time. Okay, so depends upon the duration, he going to perform different kind of operation. Okay, so the here the object is same. Okay, the object is same, but the way it behaves, way it works, okay, will differ according to the situation, according to the functionality, right? So this is called polymorphism. So another example, frequently they will refer shape. So shape is a object or class. Okay, you can derive a different types of classification. Okay, shape could be circle, shape could be circle. Okay, shape could be square, shape could be square, shape could be triangle. So if your same class, if your same class going to do different operation, if your same class going to do different operation or different implementation, then it holds polymorphism. Okay, changing its functionality. So abstraction, again, abstraction is hiding complex implementation details and exposing only the necessary functionality, ensuring a cleaner interface. So it is like hiding. So the important task is hiding the complex implementation. Suppose if you're going for an ATM, okay, you don't know what are the hardware implementation, what are the specification ATM machine have, but it will serve your purpose. It will serve your purpose, right? Take an example of this image. Okay, take an example of this image. So you're driving a car. Okay, you are very new to car and you know just driving. You don't know what are the components inside, how it is functioning. You are not a mechanic. Okay, so this is like abstraction. You are driving a car without knowing the full detail. So what car manufacturer will do? They will hide all complex implementation. They will give some access like steering, gearbox, okay, consoles. Be able to know only few information about your car. Okay, so with few information, you able to drive the car. So this is an example, beautiful example of abstraction. So using abstraction, your life is very easy. Okay, if you don't know abstraction, if you want to know each and every details, the life will be more complex. So take an example of uh, automatic car, automatic car, and gear car. Okay, so gear, you know each and every gear, you able to operate individually, you able to operate individually. Okay, able to control, finest control. Okay, so this is without abstraction. So here they are not hiding the gear information, but in automatic the machine will take care. So here they are doing abstraction about gear, abstraction about gear system. So is it clear? Are you able to follow what is an abstraction? So next we try to define what is a class. Okay, so class will act like a blueprint for creating an object. Okay, so we try to create object, we try to do programming for object, real world object, but we need abstraction. So you can think class is an abstract entity of an object, abstract entity of an object. So it is like an idea, it is like an idea. This is real physical object. Imagine like this, real physical object. So what class will do? Class will define the attributes, data, and methods function that operate on the data. So actually these methods and function going to operate over data, going to operate over data. Okay. So an object is an instance of a class that has own unique values for the attributes defined in the class. Okay. So instance is nothing but copy. Instance is nothing but copy. Okay. So take an example of a class. Take an example of a class. You're creating a copy out of here. You're creating a copy out of it, and that is called object. That is called object. Okay. So this is like original. This is like original, and you are creating just an copy. Just an copy. So what is more important here? Your original thing is more important rather than object. And you can create multiple copies out of it. You can create multiple copies. So this is copy 1, this is copy 2, copy 3. So this is object 2, this is object 3. So if you have a single copy, single class, you can create multiple objects out of it. Okay. To create an object, class is must. To create an object, class is must. So class come first. Class comes first. Object will be followed. So class is more important rather than object. So if you want to do object-oriented programming, okay, you need to have a better understanding about how to create a class. So take an example of a person. Okay, so consider a person like an abstract entity, like a class. So a person could have attributes like name, age, gender, occupation. So all these stuff are related to attributes, or you can say properties. So each and every textbook, they will differ slightly according to the language. Okay. So the person can do so many functions. So he can walk, he can eat, he can sleep, he can work. So according to the time, the functionality will change. So this, in some language, they will call as method. So I will give you a brief idea. So according to the language, this terminology will little bit differ, right? So take an example of a car class. If you have a framework, if you have a generic idea, if you have generic idea about about car, okay, then you create multiple different car variety. Take an example of Maruti, take an example of Audi, take an example of BMW. So the idea is same, but how it is built, how it function, how it works entirely depends upon how we are creating from an idea, how we are developing. Okay, so all these cars have a commonality, so between class, commonality between class. So whatever the class defines, whatever the class defines, okay, both the data plus function equally implemented to all these type of car. But here the variation will come. Okay, at object level variation will be there, but the commonality will be found in base class. I hope this will be have some clear definition about class and object. Any doubt? If you have any doubt, please ask me, because this is very important slide. Okay, fine, fine. Yeah, we'll discuss. We'll discuss. Wait for a minute. So we will have some example in Python. Okay, so how to create a class, how to define function for it, and what are the attributes you're able to create. So here you can see So here you can see, so line number 1, we are defining class. We are defining class. So class is a keyword. Class is a keyword. Student is class name. Class name. Or you can say it is a variable. Okay. So the line 1 to 4, 1 to 4 is a function definition along with 5 to 7. So whole line 1 to 7 belongs to class definition. Okay. So this class definition contains some details about the class. Okay. What are the details? It can define about the data. It can define about the method. So look at line number 2. Here we are defining a function. So this is a keyword. Class is a keyword. Def is a keyword. Okay. Self is a keyword. Init is a keyword. So these are system defined keywords. Already these keywords have some meaning. So this is what I say. Right? Self is a keyword. Right. So that's all. So look at line number 2. We are defining a function. So line number 2 is function definition. Okay. So what we are doing, we're going to do initialization. Initialization. Okay. So for that, we are passing 3 parameters. So these 3 are called parameters, or you can say input arguments. Okay. So you can say in multiple synonymous word. It could be parameter, it could be input arguments. So here name belongs to the student. Name belongs to student. It is one of the data. It is one of the data. And branch also one of the data belongs to student. So we have 2 data, right? These 2 data are able to store in a variable. So if you have data, you need to store it. So where will you store? You are able to store in a variable. So in programming, if they are saying variable, it gives some space to store your data. So this is what it means. Okay. So name is a variable, branch is a variable. Okay. We're going to associate with object, class. So self is referring to the same class. So it is a reference to the same class. Okay. So what we are doing, we try to associate this variable name along with that class. So whatever if we are giving input, it is get stored in your name variable associated with your class. So here it is nothing but it is like student dot name. So try to imagine like this. So look at line number 3. So it will operate in this way. So whatever if you are giving input, that input is stored related to student dot name. Same way if you are giving any input for branch, it will be stored in the student dot branch. So instead of referring that student, we are referring a self-reference variable. So look at line number 6. Line number 6, what we are doing, we are defining a function to the class itself. Okay, here input is the class itself. What we are doing, we try to return. So this is the function. So this is function definition. So what this function will do, it is given in line number 7. So it will return something. It will return something. So what it will return, it will display. It will display. So what it will display? Student colon self dot name. So whatever you gave input, that input is displayed over here. So student colon that name. So next, what it is giving, branch colon self dot branch. So this branch is displayed over here. Branch is displayed over here. So try to understand line one by one. Okay. So look at line number 9. So what we are doing a function call. So we are doing a function call. Okay. So here what we are doing, we are creating two inputs. We are giving two inputs and we are passing for this function. So R1 is related to name. Okay. So IT is related to branch. This R1 is stored at here, IT is stored at here, and what you're going to do, you're going to do a function called print. Okay, this is a function. This is predefined function. This is predefined function. So already all these meaning are written in Python. So no need to care about this, right? So what we are doing, we try to create an object out of your class. We try to create an object out of your class. Okay. So here we're going to create an object. So this is your class. This is your class, right? This is your class. So here we try to create a copy out of your class. We are passing two parameter. So student1 is your object. So here we are calling a function called display.info. Whatever the information you created, store under this object. So it is like student1.name, which contains R1. Okay, next student1.branch, it contains IT. I'll share this code. Please go and run and able to get the output. The output is student colon R1 branch IT. What I do, I try to share that code with you. So I try to copy this code. I'll put in chat box. So copy this code. Go to online Python compiler. So here I will share a sample website. You can go to any website. Sorry, I shared C compiler. I'll share Python compiler. I want to copy this code. So try to run this. You able to get the output? Are you able to get the output? Good, good, good. Okay. So alternatively, what you can do, you can install Python in your editor. I'll share that link. So if you're new to computer science and Python, so go to this website, try to install the latest version for Windows. So installation is very easy. Once you install, open your IDE in this way. Okay. Here you need to paste. You need to paste. Then you need to enter. So actually, some space we need to give very carefully while working in IDE, right? Next, you try to run this code. Now the object is created. Then try to call method using int. So multiple ways you can run. So try to paste only these code, only the two function. Then press enter. Okay, come out. Then give these two lines. It will perfectly work. Yes, you can do any method using Colab also. You can work. Okay, you can use IDE. You can use online editor. Whatever you feel comfortable, you can use. No restriction. Okay. So we covered a simple program. We covered a simple program how to create an object out of a class, right? So next we are about to discuss. We are about to discuss the classes are static structure that define behavior but do not consume significant memory on their own. But whenever you try to create an object, whenever you try to create an object, create an object that are memory consuming entities, each and every instantiated object, it is like copy. Okay, copy requires memory allocation for storing attributes. So whenever if you are creating a class, it doesn't affect. But whenever if you are creating object out of your class, you should be very careful. So this is what it means. So classes are static. Classes are static where objects are dynamic. So always in nature, okay, dynamic element, dynamic simulation or dynamic interaction is very complex in nature. Okay, very difficult to manage. So in programming also, you need to be very careful when you create an object and how many times you are creating an object, that many memory spaces you need to allocate each and every time. Okay, as the number of object increases, so does the memory consumption, since only the attributes defined in the class contribute to the memory footprint of each instance. So you should give more importance for class creation. So depends upon your class, object will be created. Okay. So whenever if you create a class, you need to think how to allocate memory. What are the necessary attributes you need to create? So this is very essential for a programmer to create efficient program, right? Each and every object will occupy your memory. Each and every object will occupy your memory. Next, we're going to cover the second key point, encapsulation and access modifier. Okay. So encapsulation is a technique of restricting the direct access to your object attributes and methods while providing controlled access. Able to prevent the access by using encapsulation. Okay. So why we need to do? Because it will prevent accidental modification and enhances security. So you cannot give access to your object or class. You need to restrict. Okay. So how you can do restriction in different levels? So you can do at public attribute, you can do at protected attribute, you can do at private attribute. So even in a normal scenario, okay. So zoo or public park, anybody can go. But for some government office, okay, restrictions will be there according to the floor, according to the level, according to the hierarchy, they will restrict you. So if there is a military wing, okay, if there is a military site, okay, vigilance, you cannot enter easily. You need to get permission, you need to have privilege, then only they will allow. In the same way, you are able to access this object retrieval, right? So we'll discuss one by one. Public attributes are accessible from anywhere in the program. If you are writing a whole program, if the attribute is public, anywhere you can access it from anywhere in your program. Okay. If you're writing the protected attributes like restricted places, okay, you need to have some permission. You need to have some permission. So should not be accessed outside the class, but still are accessible if necessary. So if you have permission, you're able to visit. But if you are inside class, you are able to access, but outside you cannot access. Okay, here we are putting some restriction. In private, prevent direct access from outside class, enforcing encapsulation. Right? Encapsulation can be implemented in different levels according to the attribute nature. We can implement. Right? So Python doesn't enforce strict access control like Java, C, C++. Sorry, Java, C++, because we are dealing with the object. Okay. So C will do in different way, right? Python doesn't enforce strict access control like Java and C++. So next example is like bank account. Okay, I'll share this code. First we will discuss. So line number 1, I'll try to change color. So line number 1, class bank account. So this is called class definition. So line number 1 is like class definition. And you need to know how long it will go. So class definition will go from line number 1 until line number 16. The whole area is called scope. So scope of your class definition. Okay. So line number 2 is function definition. So here we are defining the initialization function. It contains 3 attributes. Okay, one is to itself, the second one is account holder, the third one is balance. Okay, in line number 3, whatever you are giving the input parameter, that is stored under this variable. Same way, whatever if you are giving balance, that is stored under class.balance. So look at line number 6. Okay, we are creating a function called deposit. Okay, here it will refer to itself with the given parameter amount. So this is one input. Okay, so we have two inputs, sorry, 3 inputs. This is input 1, input 2, input 3. So imagine like this. So whatever you are giving input, that is added with your balance. Added with your available balance. So if you are coming from different background, little tough to understand this notation. So here you are seeing plus equal to. So this is called shorthand notation. start and notation. Take an example of A equal to A plus B. Okay. So you can write in shorthand notation A plus equal to B. So this is what it means. Is it clear? What is plus equal? Whatever the balance is there, balance is added with the amount B. Okay. So next, look at the line number 9. I will clear all these notes. So look at line number 9. Here we are defining a function called withdraw. So we are about to withdraw from bank account. So we withdraw from the bank account, that is referred to self, and how much amount we need to withdraw and what we need to do. We need to check whether the amount is sufficient from the remaining available balance. Okay. So if it is available, we can do subtraction. We can do subtraction. So this is like balance equal to balance minus amount. So in shorthand, we gave minus equal to amount. Okay. So we need to check condition. Why? Because we are withdrawing whatever the amount you given. If it is not sufficient from your balance, okay, then you need to display this message. So this is like output. Yeah, what you can say, warning to your customer. So you have insufficient balance, right? You need to notify your customer, right? Then next we think about getting balance. If you want to know how much balance is remaining in your account, just you need to refer that balance variable. So next what we are doing, we try to create an object. So account equal to bank account. We are passing two parameter. One is Alice. The second one is 1000. Okay. Refer the previous slide. So whatever you are giving the input one is account holder name. Okay. The second input is balance. So that is stored under initialization. We are creating an object from a class. Are you able to get? So this is your class. Okay. We are creating an copy. This process is called instantiation, and this is your object. Now the account dot, right? Account holder will have this value Alice. Okay. So next, account dot balance will contain value 1000. So this is what it means. Are you able to follow? We are passing two parameter. Okay. With the help of two parameter, we are creating an object. So how to print that object? Value by using print account holder. It will print the name of that account holder. Next, it will print that balance account value, right? So next, what I do, I'll share this code with you. So if you are making any mistake in this space, it will show error. So we should be very careful whenever if you are working with Python. And we need to use the same indentation. Oh, okay, fine. I'll tell. Now we will run in online compiler first. Then we'll check whether it is working or not. Working, fine. I'll share in chat box. So try to run this code. Try to run this code. I try to zoom this window to explain what is indentation. So if you press enter, right, the next control will come over here. Here you need to give tab space. So this is called indentation. So this space is called indentation, right? Then after this line, you need to press enter key. Then you can see difference over here. Again, you need to give tab space. So line number 3, line number 4 will come under line number 2. Line number 2 will come under line number 1. So this hierarchy is called indentation. Are you able to follow? So if you are looking at C++, we'll use curly brace. Definitely it is mandatory to give indentation, otherwise you cannot create structure in Python. Thank you, thank you. So you can see the structure. Okay, this dotted line, this is called indentation. Most of the time in Python, people will get this error. So for an example, if I am giving a wrong indentation, so return will come under the same hierarchy of definition. You try to run, it will throw error. It will throw error. Are you able to get the idea? Because we are giving wrong indentation. So all of you got output? Okay, great. So this is your output. This is your output. Okay. So what you are doing, you are giving a class and you are passing two parameters. You are creating an object account. Okay. You try to print the three values. The one is account holder name. The second one is account balance. The third one is also account balance, but you are getting in two different ways. So that is why you got Alice for first print, 1000 for second print, and 1000 for third print. So next topic is data storage. If you are having some variables, okay, if you want to store your data, you need variables, okay. So we try to compare with C language. So more in depth, we can see how the data are stored rather than Python, right? So storage class it divided into two. One is automatic, one is static. Okay, if you are running a program which demands memory runtime, okay, then you can go for automatic, like auto and register. Okay, if already know your data, if it is static, okay, then you can go for static or external. So this is basic storage class in C. Okay, then if you're looking at data types divided into two versions. One is primary data type and secondary data type. Okay, primary data which is already given, primary data which is already given in your software, given in your software. Okay, otherwise you can call built-in data type, built-in data type. But if you are looking at secondary data type, here user able to define your data, user able to define data, define data according to their demand. So this will give freedom for the user, freedom for the developer. Already the predefined data type is there. Okay, you can use all this predefined data type. We are able to create new data type out of it. So that is why sometimes it is called derived data. We are able to derive a secondary data from primary data. I try to cut short. Okay, try to cut short. Okay, so data type you can define into three categories again. One is primitive, which is system already defined. So you can use all these data type to create a derived data type, and you can be able to do user defined data type also. Okay, in derived also you can do user defined like enum and structure. So difference between C, C++, or Python or Java. Okay, if you have class and object, if you have class and object in this side, you can create the same phenomena using structure. So structure is equivalent to class. So whatever you do, you able to do in object oriented, you able to do in C also. So this is I want to highlight. Okay, but here you need to manage. It will be little more complex when compared to object oriented. Here development rate is fast. Here coding development rate is fast. Here it is slow. Okay, because user need to manage each and everything. Whatever you able to create with class and object, you able to do with structure in C. Okay, so these are the data types available in C, and these are the memory size, memory range, or data range available in your data type. Okay, so take an example of char. Char is a character. It could be A, it could be capital X, it could be any single character. Okay, so that is why the storage takes only for 1 byte. Storage takes only for 1 byte, right? So I cannot describe each and everything in this 2 hour. Okay, in your free time, please go and check. So all this data type, what are the range, and how you are able to print your data. Please go and do. I try to do one or two stuff if time permits. Yes, please put in chat box if you have any, somebody raise their hands. Any doubts until this? Okay, great. So I try to give difference between bit and byte. So byte is combination of bits. Definitely I will provide slides. Definitely I will provide slides. I will provide programs. You can try on your own. So don't worry about that. Okay, try to get the grasp or glance of all those topics. So depends upon your data. Depends upon your data. Size is determined. Size is determined. So who will decide all this stuff? The developer. So developer need to understand the problem. Understand the problem. He need to pick the suitable data type. He need to pick the suitable data type. So according to the choice, according to this choice, the size is allocated for the data. Okay. I try to write a simple program. I try to write a simple program. I'll give a PDF book, definitely. I'll copy this code. I try to run in online C compiler, if it is possible. So here indentation doesn't matters. Great, working. What I do, I try to explain the program line by line. I make it simple. Int D or int A. Size of A So look at this code. You can give indentation. It is your choice. Okay, now it is looking like properly structured program. Okay, so line number 1 is header file inclusion. Yes, 4 bytes. It depends upon the compiler. The size will vary. Okay, so if you are running in different compiler, some compiler will take 2, some compiler will take 8. So it depends upon the compiler. Okay, so line number 2 is function definition. We already covered in Python. Function definition. So here the function name is main. Okay, so what is the type of function? Is int. So data type, then function name. So here you can see like int main. So what it means, this function will return integer value. This is what it means if you are giving int main. Okay, suppose you are defining void main. For an example, void main What it means, this function will not return any value. So in that case, you need to delete this return statement. So we are giving return 0 means 0 is an integer. So try to run this program, it will give output. So if you're giving int main, it should return integer value. So 0 represents successful. Your execution is successful. So this is what it means. Okay. So if you're giving void, so nothing is there. Void means nothing. Void means null. So that is why no return statement. That is why no return state. I'll try to explain one by one. Okay. So if you're giving int a, so a is variable name. So if you have RAM, if you have memory, so consider if you have RAM or physical memory, you can say like physical memory. Okay, it will allocate some storage space. So this will allocate storage space of variable a. Okay, so this online compiler will allocate 4 byte for integer. So according to the compiler, the size will vary. Are you able to get? Okay, fine. So next what we do, we try to assign some value. Maybe in next line I try to give a equal to 3. Imagine. Okay, you want to access that value. What will give? Printf a equal to %d comma a. So try to run this. Yes. What you do, you give slash and before this to avoid confusion. So what it will do, it will allocate memory space. So line number 4 will allocate memory space and line number 3 will store your data. Sorry, line number 5 will store data 3. So this is due to line number 5. Okay. So line number 6, it is a function call. Line number 6 is a function call a equal to %d. So this is a integer. This represents integer. Okay, if you want to print integer value, you need to represent %d. Okay, followed by a. So what is the value stored in a? 3. That is why a equal to 3, it is printed over here. You are able to get the output. So people from computer science, please pardon me. This is very basic, but I cannot skip. So line number 7, what we are doing? Line number 7, what we are doing? We try to print the size of a %u. %u means %u will print memory size. Okay, U stands for unsigned integer. So memory space is somewhat larger. That is why you need to have a different format specifier. So D only holds integer value. If you want to represent the memory related stuff, go with %u. Okay. So next what we do, we try to modify data. I try to zoom in, float. Here we need to modify a little bit. F 3.78, make it like that. Try to run this code. Now you can see the difference. Okay. So you can give a long int also or double. You can change your data type. So refer the format specifier, double LF, right? LF. Now the size is increased. Are you able to see? So this compiler for integer, for float, it will assign 4 byte. Okay. For double, it will allocate 8 byte. So your data type decide your storage space. Your data type decides storage space. Is it clear? Shall we move to next? Okay, great. Thank you. Thank you. We try to create an array. How you going to save your variable differs. Okay. Again, I will go to compiler. I try to create 3 variables. Int a equal to 2. Okay. Int b equal to 3. Okay. What I try to do, I try to print address of that variable. Address of a %u ampersand a. Okay. I'll copy the same line. Address of b %b. Here I'll give /n. We no need the statement. I try to run. First I'll check. Great. Okay. I'll zoom it little bit for your convenience. Okay. Yes, you can put a message Gianch. We need to check with the compiler. We need to check with this compiler. Let's discuss the basic stuff. So this is a RAM. Okay. RAM stands for random access memory. Random access memory. So what it means, your RAM contains so many storage space. It is like a building. Okay, it contains several floors. Whenever if you are creating a variable a, it will be stored anywhere randomly. Okay, so take an example of address. 766482204. Okay, in this address the A is stored, and what is the value? Value is 2. So next what we are doing, we are storing B in somewhere else, and what is the address value? 766482200. So this is somewhat prior to A. B equal to 3. Okay, the way it is stored, two independent variable at different space, at different memory location, and how it is storing? Purely random. That is why the memories, whatever you are using, physical memory is called random access memory. It will store any variable at any memory space. Okay, so next what we do, we try to create an array. Array is sequential memory storage. Okay, so it will store the same type of data, same type of data under common name. Take an example, we need to store two variables, two value, but we need to store subsequently, next to next. So this is our idea. So our idea is to store two value, A equal to 2, B equal to 3, next to next. So this is very easy. If you want to access this data, it will take very less time, right? So what we do, instead of creating two variables, we will create the same variable 2 with the size 2 equal to
We are not giving anything, we are giving only you. तभी एक ले लो कोई। नहीं उसका तो टैक्स कट के ना सर पूरा हम 31% काट के देते हैं ना ये जी।
So this will create two values. In your memory. Okay. So what is the name you gave? A. So A have subscript of 2. It means it will allocate 2 memory space. Okay. How it will store? A of 0, A of 1. So 2 is stored under A of 0 and 3 is stored under A of 1. Yes. Array size is 4. That is why the size is 4 byte. Okay, so each variable contains 4 bytes. The total size is 8 byte. The total size is 8 byte for this array. Sir, some voice is there. Hello, sir. Hello, sir. Some voice is there. Yes, sir. Yes. Thank you. So what we do? We try to create a long double. We try to create a long double D. right? We try to create an array of 1000. Okay, we're going to implement this program. Let's see. Okay, the size of double is 16. Let's say if you're creating 1000 variables, okay, so 1000 variables, what is the size of double D? It is 16 byte. 16 byte multiplied with 1000 variables, that is why 16,000. So all these variable created stored next to next in sequential way. I'll share this code with you. I'll share this code with you. Try to check. So many windows. I try to close each and everything. I'll cover dynamic memory allocation if time permits. So let's see how the memory management's work will in Python. Okay. So memory management involves temporary data storage needed during program execution, like variables and literals. Okay. So as program expands, efficient memory management become crucial to maintain speed and efficiency. So how you're going to allocate your memory, how you're going to manage memory will decide speed and efficiency, right? Especially in Python, which powers large scale application in terms of AI and data science. So if you're interested in AI and data science, you need to know how to manage memory efficiently. So what I suggest for you, please go through C, try to understand the memory management concept, try to master it, then come to Python. So C is somewhat tough in terms to memory management. Okay. So let's discuss how Python memory allocation will happen. Okay. Python have memory manager. So C doesn't have memory manager. Okay. Python have memory manager. So it is a part of your software. It is responsible to manage memory allocation and deallocation to various process. Okay. So this will take care about your memory, right? Two ways it will do. One is static memory, another is dynamic memory. So static memory is all your input, all your process, everything is decided beforehand. Before running your program, everything is decided, settled up. But dynamic, during execution, you're about to give some input, you're about to do some process. Okay. So static is somewhat easy, dynamic is somewhat difficult, and you need to be very careful about dynamic memory allocation. Okay. So all these functions we declare in Python code has each of this memory associated with them. Okay. So according to the type, you can choose. Yes, programming definitely have memory management. So without knowing memory management, we cannot write efficient program. So memory is part of your computation, isn't it, sir? So we know the variables are reference to the memory address. Let's dive to see how the memory is allocated for a variable, how the CP access memory location, and how the memory code use is cleared when the execution stops. So this is memory management. Your coding will clear memory, but in C, you need to take care. When code runs, okay, if it is running, if it is a process, okay, so I need to give a little clear instruction for non-CS background. So if you write a program, it is static, right? If you try to run, compile, or you can say execute, it becomes process. So process is nothing but your program which is in run state. Okay, which is in run state. So each program is allocated some memory in terms of stack, some memory as heap, some memory for code segment. So there are different types of memory according to the variable. Your memories get allocated. Okay. So first we discuss static memory allocation. So whenever a new function or class is declared, it is very common to have same variable declaration inside them. Okay. So these declaration are associated with the function itself and do not change in runtime. So that is why it is called static. It will not change during the runtime. So take it an example like constant. So some value like pi, it will remain same throughout course, throughout entire course. Okay. So those type of data you are able to store in static memory allocation. Okay. They occupy a fixed memory size. It is very easy for the programmer, developer to maintain it because the memory size is fixed. You know the problem. It will take only this much time, this much storage. Then you go for static memory allocation. Okay. Hence, these are stored in a stack area. So stack is like the inverted box. We can say, so this is called stack memory. Okay. So whatever if you are putting as input, you're able to take as output. So first in, first out. Okay. So if you're storing A, it will go to the bottom. If you're storing B, if you're storing C, so everything is topped up. If you're taking the output, C will come first, next B will come, next A will come. But when you are giving input, you gave A, then you gave B, then you gave C. So this is completely different to a RAM, right? We discussed wherever it is allocated, it will get stored. For each and every stall stack allocation, okay, every function call in Python, there is a structure maintained in memory process. This structure is called function block. When you create a variable, okay, when you create a variable for each and every function, okay, it will maintain some memory process. So Python memory manager will maintain all the stack like function blocks. So when you create any variable, everything is managed with the help of Python memory manager. In C, you don't have memory manager, a developer need to manage. So this is an example. So what we are doing here, so line number 1, we are defining function. We are defining function. Okay. Then we are creating three variables. So all these variables are stored as function block, like stack memory, right? So next what we do, we try to discuss with dynamic memory. Heap memory is separate from static memory. So this is can be represented for dynamically allocated data. If there is a request, it will get allocated. Okay. If there is purpose solved, it is released like deallocate. So if there is a request, it will allocate memory. So after process, after task accomplished, okay, that memory space is deallocated. So it is like a reservation. So until that computation, memory space is available. After computation, it is deallocated. So this is called dynamic. This is called dynamic. So any point of time, the memory is allocated, deallocated. But in static, it will remain same. It will remain same. So that is why memory size is required for such variables cannot be determined beforehand. Hence, we need to use dynamic memory. So most of the artificial intelligence, data science, whatever you are doing a real-time application, most of the application requires dynamic memory allocation, which is scale up and scale down, right? So take an example of array. You don't know what is your array size. Okay. What you can do, you can get the number during the runtime. So you don't know what is the array size. You can create array during runtime dynamically. So what happening over here? We are getting input. Take an example of 5. So array size is 5. Okay. It will convert into integer. It will stored in number, and array 0 is multiplied with the number 5. So 5 number of variable are created for this array. Number of variable are created for this array. So this is an example for dynamic memory allocation. Okay. If you want to deallocate memory after doing computation, so what you can do, you can go through reference counting or garbage collection. So C++ doesn't have garbage collection, where in case of Java, Python having garbage collection. So this is a memory management tool. So after computation, your software will take care about your deallocation, right? So that is what it is discussed. An object is removed from the memory when its reference count drops to 0, releasing it to memory back to the heap for future use. So once the task is accomplished, okay, the same memory is retrieved back to memory bank. So uh, how they are managing garbage collector? They are running periodically. So according to timeline, okay, they able to do allocation and deallocation. They try to eliminate which are all the unused memory are already accomplished. I'll skip all this stuff because it will take some time, right? This I want to highlight. The whole Python is derived from C. The whole Python is derived from C. So most of the time, it will implement using C. The primary language is C. Okay. So if you want to implement anything efficient in very time reduced way, you use C Python. Okay. Um, okay. So to understand the better memory address, we'll go for C language. Okay. When a variable is created in C, a memory address is assigned. So we previously discussed. Okay. The memory address is the location of where the variable is stored on your computer. Okay. So when we assign a value to a variable, it is stored in the memory address. If you refer that memory address, you able to discuss. Definitely, I'll come to the pointer. Please wait. That is what I am going through. To access it, use the reference operator and the result represents the variable is stored. Uh, Take an example of int my age equal to 43. So this is the variable. So what happens? It will store somewhere my age equal to 43. Okay. If you print that value, you can use dot percentage %p. So this will help to the pointer. Okay, this will help to the pointer ampersand my age. Okay, so ampersand stands for address of operator. Address of operator. Star stands for value of operator. Value of operator. Somebody more interested towards pointer, if time permits, I will complete that first. Very interesting topic. So let's have a small program about pointer. I will introduce void. I can reduce one more line. So int a equal to, okay, a. Next, what we do, we try to create a pointer int star p. Okay. Next, we try to associate pointer to the variable a using ampersand. I try to explain each and everything step by step. So imagine this is your RAM. This is your RAM. So randomly it will store anywhere in your memory space, right? So int a means it will store anywhere, some memory space. Imagine int star p means it is a pointer. Is a pointer. It is also stored somewhere else. Okay? We are creating a pointer. We are creating a pointer and associating with variable a. So what it means? A is stored under some memory value address 1005. So this is memory address. Okay. What we do? Ampersand is address of operator. Address of operator. So ampersand of a means address of a. What is address of a? 1005. So address of a 1005 is stored in P. Is stored in P. P now contains 1005. P contains address of A. So this address is stored in P. That is why it is called pointer. It is like a direction board. It is like a direction board. Okay. It will point to some variable. It will point to some variable where it is located. So if you want to know location of a particular variable, you can use pointer. So is it clear? Shall we move? If you have any doubt within this pointer, you can ask me. We are creating one variable, line number 4. I will move this. So line number 4, we are creating a normal variable. Line number 5, we are creating a pointer variable. I want to highlight what is the meaning of star. Star is value of. Value of. So what is the meaning of star? P, value of P. Value of P. What is the value of P? 1005. Okay. So this is about star of P. P is pointer variable, that's all. If you refer only this location, that is P. If you are referring 1005, it means star of P. Somebody has question, right? Are you able to get difference? P is pointer variable, star of P is value of pointer variable. So go through this slide. If we clear, we can move. Okay, good. Okay. We cannot drop line number, we cannot drop star. The star means it is a pointer. Star means it is a pointer. Otherwise, you cannot know the difference between A and P. So imagine if you are creating like this, it doesn't have any meaning of line number 6. It is not pointing, it is only storing. You can store address of A to the variable P. It is not a pointer. It holds only the value. So there is no relation if you are doing like this. Clear? Okay, great. What we do, we try to print value of uh, A using pointer. We try to run. If you understand this, you can understand. So this is garbage value. We didn't assign any value for A. So that is why, right? Now we discuss with visualization. Easy for you. So imagine A is stored somewhere else, P is stored somewhere else. Okay. So what is the value of A? Value of A is 6. What is value of P? Value of P is address of this A. What is the address? Imagine 7008. Okay. The value is stored over here 7008. Okay. This is what it happened. You are able to access the value of A via P, via a pointer. So you can indirectly access variable A. Okay. So next what we try to do, we try to print the address of A. I'll put slash and before this new line. Okay. How we are getting address of A? With the help of P. Here you need to modify U. So it is giving 898586 Okay. The same line you can copy, you can paste. You can give address of A. Are you able to get the same answer? So what is address of A? Address of A is assigned 4148108420. This address is stored over here. So forget about 7008. So what is ampersand of A? Address of A. Okay. So what is P? Again, it is address of A. So this is what it means. So using pointer, you able to change the value of A also. You can indirectly change value of A. So this is what we discussed. Instead of PPT, I shown the program. All right, fine. So this is the book we are creating for QT-03. I extracted from this book. I try to share with participants once it is finalized. Okay. So this will be material for you. Each and every topic contains so many programs. So within 2 hours, covering each and every topic is burden for you. We discuss data structures, a linked list, stack, only basic level. You we try to share once it is finalized. It will be heavy for other school participants, other domain participants. Okay. So if you have any doubt, you can put in chat box. We can discuss. I keep it very simple. I'll share the book in Canvas, or I'll compile all the programs related to all these topics. A simple program. So any other doubts? In
Thank
all
you, sir.
languages,
I
yes.
would request candidates, if you have any question, you may ask, sir. And as said by the sir, the PPTs will be shared once it is finalized. Okay. And I hope now onward you all have got the Webex link. And definitely the attendance part we will be looking after this session. We will look for that one. We will resolve the problem of why some of you have not able to register the your attendance. So meanwhile, you may ask question, raise your hand, just put your question in the comment box. Something in the comment box. Sir. Jay Kumar sir, I think there are some comments.
Yes, sir. Yes. So Python have very beautiful memory management, and Java when compared to C and C++. C, we need to take care, developer need to take care. It is developer responsibility. Modern language have memory management as a software feature. The role of data structure in quantum algorithm, we are not yet clear. The basic data structure we are using so far, but we need to understand how it is working in classical, because most of the time we are writing program through classical perspective. Maybe new type of data structure will be available in quantum. We don't know. We don't know. It is evolving. Great question. Quantum programming session will be there. It will come after 10 classes. It is based upon classical. So if you know classical better, you can understand quantum better. Nobody can say which is the best language. Each language have some purpose. Okay. So if you are in northern India, Hindi will cover most of the part. If you come to southern part, according to the region, you need to speak. Okay, same happens for quantum platform. So how you are designing your system, which language you are using, it is best suitable. So that is why they are developing Quassim. So if you're not aware about this, you can check open Quassim. Okay. So this is a standard where all quantum vendors are using. Suppose if you are writing a Python code in Qiskit, IBM Qiskit, the same code will be converted into Microsoft Q Sharp. I try to share about open Quassim. Very good question. So go to this open quizzing. You can use any quantum language, quantum supported library. This will support. So irrespective of your tool or platform, you can convert into any quantum language or quantum supported package. So if you are working in Google, if you are writing program in Google Circ, it will be automatically converted into Qiskit. You can use any packages. It is according to you. So I basically prefer Qiskit because it have very good library and repository, very good support system is there. So huge user base. That is why. Now Python is very easy, but in future they will integrate to C and they will integrate to Rust, more towards to these two languages. Space complexity and memory allocation are almost same. Space here we are defining about the memory space. I try to do. If C is not oops, still it hold same data allocation. Yes, any language you are using, you need to store some data, then you need to compute. For that, the memory management is needed. Okay, the way you are storing that is different, but anyway we need to store. If you are writing Qiskit program, okay, a Python code that is converted into language neutral. So Quasm is converting everything into language neutral. So Qiskit, I will mention this is IBM Qiskit. If you're using Open Quasm, okay, it will convert it into Google Circ, or it will convert it into NVIDIA QCODA. Okay, it will convert into any language. So vice versa. So it is language neutral code. So all software will support Quasm. We will discuss during that Qiskit implementation. Quasm is a tool developed by CDAC. Quasm is a tool developed by CDAC. I try to share that link. So all these tools are covered. Will be covered in upcoming session. So don't worry, don't hurry. Right, we have enough time. Okay, thank you all. Any more doubts?
Thank you so much, sir.
Thank you, sir. Thank you.
So participants, there are so many questions apart from the session regarding the attendance. We are looking after that one, so you don't have to bother about that, and don't flood this message again and again. We are looking after each of the minor issues that you are facing. And so tomorrow there is, I think, there is no session. So we will meet on Monday, the same time, 2 to 4. So with this, we may conclude the session. And thank you all the participants and Shivan sir for joining.
Yes, sir. Thank you for hosting this session. And Jayakumar, sir, this was a very informative session. Thank you.
Thank you, sir. Thank you.
I think we can stop this session.